vertebrae, different parts of the vertebrae to be aware of. Let's see if I like it better. Okay, guys, is that better?
Yes.
Maybe a little bit, not quite as sharp. 1 and 2. Anyway, all right. Vertebrae, parts of like a typical vertebrae to know. What's this part of a vertebrae called?
Body.
Yeah, that's the body. Okay. Now, if you go from here all the way across, what's this called? The whole thing together is called the vertebral arch. Okay. What's the center hole called? That's the vertebral foramen. What's inside that central hole? Spinal cord, right? Now, if I go back to this arch, there's a couple parts that make the arch. Okay, the little connection right here from here to here, or from there to there, those are called the pedicels. The connection back here from there to there, or from there to there, are called the lamina. So, pedicel, lamina, and another pedicel, that's what actually forms the vertebral arch. And then coming off of that vertebral arch, you have all these processes, these different projections, okay? And there's a total of 7 of them, okay? You have, what's the big guy that goes out back? What's this guy called? Yeah, that's the spinous process, okay? What are the processes that come off to the sides called right here? Those are the transverse processes. And then you've got 2 processes that go upward, here and here. And then you've got 2 processes that go downward. These are the superior articular processes. The ones that point downward are the inferior articular processes. And remember, it's between these guys and these guys that allow one vertebrae to form a joint with the vertebrae above it or the vertebrae below it. Okay? So if I had... If I had 2 vertebrae together, they would fit just like this. Okay? Now what would be right here where my finger is? Yeah, that's where the disc would be. But if you looked around on the posterior side, now I didn't pick. Unfortunately, these aren't two vertebrae that are actually consecutive. I just grabbed whatever I could. So this space wouldn't be as big as it's shown here. But basically, you have the inferior articular processes of this top vertebrae forming a joint, forming one of those gliding joints with the inferior articular processes of the vertebrae above it. And that's how they stack up on top of each other all the way up through the spinal, for the, what's the word I'm looking for? The backbone, basically.
You mean the superior?
The vertebral column, sorry, that's what I was trying to think of. All right, so that's that. Let me talk to you about specific areas, though, specific vertebrae. The only 2 specific vertebrae that you need to know are C1 and C2. Okay? What's the other name for C1?
Atlas.
Atlas. The other word for C2?
Axis.
Axis. Okay? Now, which one is this one?
Axis.
How do you know?
The dens.
Yeah, that's the dens, also known as the odontoid process. Okay? And then, what's this one?
Axis.
Yeah, the thing with the atlas is it's basically just a ring. Okay? There's no real vertebral body to it. There's no real spinous process. It's just like a ring, right? Yes. So that when you're in the body, okay, I always got to make sure I get these ones. Hold on 1 second. Okay, that's it. When you're in the body, they sit together like this. Okay, here's the axis, here's the atlas, and they sit on top of each other. And that's what allows. What movement does that allow?
No.
Yeah, that's the no movement, and that's a pivot type of a joint, okay? Now, that's how the 2 fit together. Okay. What bone do you expect to be forming a joint right here? What bone would be there? The occipital bone, right? The occipital condyles of the occipital bone, okay? They basically be acting like, okay? Here so what's this big hole? Your foramen magnum. Right here and here are the occipital condyles. You can see they have kind of a rounded surface, kind of like a rocking chair. And they sit right on top of C1, and they just rock back and forth, and that gives you the yes move. Okay? All right, so the only specific vertebrae you need to be able to identify are the axis and the atlas. Now, for the other vertebrae, you need to be able to tell what level they're at, whether they're cervical, thoracic, or lumbar. Okay? Now, these guys, both of these guys classify as what area? What area?
Cervical.
Yeah, they're both cervical. Okay? This guy, back it up. This guy also represents cervical. Okay? One of the tip-offs for cervical is that the transverse processes of the cervicals always have holes in them. They're called transverse foramen. Vertebrae at all of the other levels do not have holes in their transverse processes. So that's an immediate tip-off. Okay? See the hole there and there that you have in the transverse process? Even if you go up to the atlas and the axis, you'll find there's a hole there, okay? Or, and it's kind of tricky to see, you got to turn it to the side, but there's a hole there, and there's a hole over there. Okay? There's something called the vertebral artery that runs through the cervical vertebrae that goes through those holes. So that's an immediate tip-off that you're looking at a cervical. Okay? You see those. Some other tip-offs are oftentimes, at least not in C1 and C2 so much, but as you get farther down, the spinous process is sometimes said to have a bifid shape. See how it's forked? See the forked shape you have with the spinous process? You do not see that forked shape anyplace else except in the cervical region. So that's another tip-off. Okay. All right. Let me go south, or inferior, on the...
Please excuse the interruption, I just have to steal one of the minutes.
All right, this is where Miguel talked about the animals. Okay, here's our moose. All right, everyone see the moose? Kind of. Use your imagination. Helps to have a good imagination. All right, and this is what looks like a giraffe. All right, everyone feeling it? Everyone see the giraffe there? All right, that's what Miguel came up with. If it helps you, go with it. All right, this one happens to be, what region is this that looks like the moose?
Lumbar.
That's lumbar that looks like the moose. Which one looks like the giraffe?
Thoracic.
That's thoracic. Now, if you want to get more technical with it, to identify the areas, there's a couple other things that you can pick up on. Okay? The spinous processes of the lumbar tend to be, so this is the spinous process, they tend to be shorter and stubbier than the spinous process of the thoracic. Okay? That's another thing. Another thing that you pick up on, and I don't know if my brightness may not be helping me here. Okay, that's a little bit better. The transverse processes of the thoracic vertebrae, as well as bodies, have a flattened area on them. Okay, the transverse processes in the bodies have a little flattened area on them in the thoracic vertebrae. In the lumbar vertebrae, you don't see that flattened area there like you do in the thoracic. What do you suppose those flattened areas are for?
Ribs.
Yeah, that's where the ribs come in. Let me see if I can do this. Okay. So, the ribs, I got the right one here. Basically, each rib comes into a vertebrae like that, a thoracic vertebrae, and it touches in two spots. The head of the rib touches on the vertebral body like that, something called the costal tubercle, which is just a little bulge on the ribs, touches the transverse process. So that's why there's those flattened facets on the thoracic vertebrae. That can help give it away. The last kind of trick to look at is the direction. Whoops. Is the direction of the articular processes. Okay? The superior and the inferior articular processes. All right? If you look at a thoracic one, like I have down here, okay? These are the superior articular processes. They basically run in the same direction as the transverse processes. Okay? Or if you look at the inferior ones basically run in the same direction as the transverse processes. If you look at the articular processes, the superior and the inferior articular processes on the lumbar vertebrae, they don't go in the same direction as the transverse process. They basically go at a right angle to it. See that? So see that difference between the two?
Yes.
Okay. That's the other thing. Another tip-off too is the vertebral body, right? Which have bigger vertebral bodies? Lumbar or thoracic? Lumbar. Why?
And supporting.
It's holding more weight, right? Everything is stacking on top, more weight of your body. There's your upper extremities, there's everything coming down on those lumbar vertebrae, whereas when you're higher up in the thoracic region, there's less stuff there. So the vertebral bodies don't need to be as big in the thoracic area. So that's another tip-off, all right? Let's see. Mentioning the ribs, oh, here's a better rib. Be aware of the ribs. There's 12 pairs of ribs total. The first 7 are considered true ribs. The next 5 are considered false ribs. 11 and 12 are false ribs, but they're also categorized as floating ribs. Why are they called floating ribs? Anyone remember?
Because they don't attach.
Yeah, they don't attach to the sternum. Do they attach to anything?
No.
Yes.
Yeah, what do they attach to?
They attach to your vertebrae.
Yeah, they still attach to the thoracic vertebrae, but they're the only ones that don't curve around in front and attach to your sternum. That's why they're called floating ribs. All right, here is a stereotypical rib. Okay, some parts to, I'm going to go up on the brightness a little bit. Some parts to be aware of. Okay, the end part here is called, now it's too bright. Actually, sorry, let me go back off of this. The end part is called the head. Okay. So the head is what touches the vertebral bodies of the thoracic vertebrae. The bump here is called the costal tubercle. The costal tubercle is what touches the transverse process of the thoracic vertebrae. The rest of it is called the body. And on the undersurface, now I really got to change the brightness. I'm just not happy with. Oh, okay, now hold on. Too much. All right, that's not too bad. All right, so every rib is basically running around like that if you look while the model spun around. But on the undersurface of every rib, there's something called the costal groove. And there's a vein, an artery, and a nerve that runs in that little groove on the undersurface of the rib. All right. Next time you're at I don't know, what's a good place? Like Bankhouse in Norwalk. Can anyone ever go to Bankhouse in Norwalk? Yeah. Order the ribs, okay? And next time you're eating the ribs, pull your teeth down across the rib as you're eating it, and you'll pull out a little bit of vein, artery, and nerve.
Great.
Okay. All right. Cows have it too. Pigs have it too. And they're good too. I'll tell you the best way to prepare a nerve later on. All right. I sound like a vegetarian. All right. Let me go on now. The appendicular skeleton. Here is what? What bone is this? Yeah, that's your scapula. There's different parts that you should know on the scapula. Okay. This happens to be a right scapula to get your bearings. So this would be sitting here on me. Okay. So let me show you the anterior part of it. Okay. On the anterior part, you have this projection over here called the coracoid process. That's an important spot for muscles to attach. This thing behind it is the acromion process. That's the spot where your collarbone, where your clavicle connects up. All right. So I guess some of these guys have it. Let's see. Okay, this guy has it. Showing you the left side, but actually, it sort of has the. This is terrible. Yeah. So anyway, this is the collarbone. It comes across. It touches the acromion of the scapula. Okay. So that's the spot where the clavicle touches. Actually, maybe I have a clavicle up here. I'll show you. So it sits like this, basically. Okay, there's a connection just like that between your collarbone and the acromion of your scapula. All right. Other parts, this part faces medially. Again, we're looking on someone like this. Okay. This border here is called the medial border or the vertebral border because it's closer towards the vertebrae. This border over here is called the lateral border or the axillary border. Does anyone remember what the word axilla is a fancy word for? If you have breast cancer and you have your axillary lymph nodes removed, where are you removing the lymph nodes from?
The outside?
Somebody said it. Armpit. okay? This is called the axillary border because it's closer towards your armpit, all right? So medial border or vertebral border, lateral border or axillary border, okay? If you look at, what's this here? That's the glenoid cavity or the glenoid fossa. What do you suppose fits against that?
Your
Your
arm.
Your arm, come on, we can do better than that. What's the arm called?
Humerus.
Your humerus,
Humerus.
right? The head of your humerus fits
It
against
was
that.
in there.
Let's see here. So, well, this one happens to be from the left side. Yeah, that's not important. All right, let me keep going. What's this one from? Yeah, that's from the left side too. Oh well. All right. So that's the scapula. Let me go on now to the humerus. Okay. Here is the humerus. This happens to be a left humerus. Okay. So again, to get your bearings, this would be sitting just like this. This rounded part here is called what? What's the round part called?
The head.
That's the head. Okay. And just like on your body, below your head you have your neck. So right below the head area would be the neck. Okay. There's two bulges up near the head. There's a bulge out here that's kind of out lateral, and then there's a bulge that's anterior. Anyone know what the lateral bulge is called?
Condyle?
The greater tubercle. Okay.
Tubercle?
Uh-huh. It's on there, right? Hmm? The greater tubercle. See it there?
Yes.
All right. Anyway, that's the greater tubercle that's out lateral. This guy that's medial is the lesser tubercle. There's a space between them called the intertubercular groove. Okay, some tendons run through there. On the front of the humerus is a roughened area called the deltoid tuberosity. That's a spot where the deltoid muscle connects to. If you go down distally in the humerus, and again, this is a left humerus. Okay. If you start lateral, okay, you have a little bulge here that's called the capitulum. And that is where your radius is going to form a joint. And then you have this bigger structure that's located medially, that's called the trochlea. That's where the ulna is going to form a joint. Let me see if I can find a better one. All right. This one's a little bit better. So, we go to this. Just give you an example. So, here's another. It's a little bit. Hold on a second. All right. Here's the end of the humerus again. Again, this is a left humerus. Here's the capitulum. Over here is the trochlea. And you can see, here's the head of the radius forming a joint with the capitulum, and this trochlea forms a joint with the ulna. All right? So that when the two bend, they follow each other. This little, let's see, tough to get these things in the face. I'm twisting the arm over. This little tiny projection that comes out there from the ulna is known as the coronoid process. And this space that's inside here of the humerus is called the coronoid fossa. Okay. And when you flex your forearm, when you do this move, the little coronoid process of the ulna, which is right there, fits inside of that coronoid fossa that's on the humerus. If you go to the posterior surface, okay, you have this big projection from the ulna. That's the olecranon process. That's the pointy part of your elbow. So that's the olecranon process. And then there's a little space on the backside for that to fit in on the humerus. That's called the olecranon fossa. All right. So when you extend your arm, that olecranon process fits inside of that olecranon fossa. Okay. Again, to give you your bearings, if you're looking at your left elbow, the pointy part of your left elbow is from the olecranon process. The bony part medial is from the medial epicondyle of the humerus. The bony part lateral is from the lateral epicondyle of the humerus.
So what happens when you
Extend.
Extend your arm and it like pops or cracks. What is that?
I was telling Mercedes before that, like when you crack your knuckles and things like that, it's gas bubbles being released from the cartilage that's there. Little gas bubbles come off the cartilage, they go into the synovial fluid, and when they pop, they cause that cracking sound.
That's the same when you crack your spine, right? When you
Yep.
scratch it.
All right, let's see, moving right along here. Let me keep working my way down. Oh, sorry, one other thing. If you look on the, it's hard, you know what, let me get a better arm. I'm not really happy with this one. Find a better arm. There it is. So again, this is a left forearm, okay? Here's the ulna located, actually let me back up, you're probably going to like to see these things. Okay. So this is a left arm. This is the ulna located medially. This is the radius located laterally. There's a roughened area on the front of the radius called the radial tuberosity. It's still kind of tough to see on this model, but the radial tuberosity is where your biceps muscle comes down and attaches. When your biceps contracts, it causes you to flex your forearm. So that's an attachment point there. If you go down to the very end of your forearm bones, your radius and ulna, there's little bony projections there called styloid processes. Each of them have it. Okay? This little part on the ulna is known as the styloid process of the ulna. Over here, this is the styloid process of the radius. So like when you feel those bones, like those two bones that you see like on your wrist that are pretty prominent, like you see a bump on the back of your wrist,
Right.
those are from the styloid processes of the radius and the ulna. The one that's lateral is coming from the radius, the one that's medial is coming from the ulna. But it's basically that little guy and then that little guy. All right. As you go down, here is your carpal joint. Okay, again, get your bearings. This is a left hand. This is your radius. And you can see the radius forms a joint with this bone and this bone. All right. The ulna, on the other hand, does not form a joint with the carpal bones. The radius is forming a joint with these two carpal bones. Any guess what carpal bone this is? So which one? It starts with an S.
No.
Not sphenoid. Scaphoid. Okay. Where's the sphenoid? Yeah, that's one of your cranial bones. So this is the scaphoid. And then what's this one? That's the L one. Which is the L one? That's the lunate. All right. So it's the scaphoid and the lunate that form the joint with the radius. Now, just to name our different wrist bones. So we start lateral, we start with the proximal row, then we go to the distal row and start lateral and go medial once again. So, scaphoid, lunate, this one sitting kind of back here is the triquetrum. Sitting sort of on top of it is the pisiform. Okay? These are two separate bones on these models because they're like made out of plastic, I think to save money. They make it look like it's one bone, but actually on this one, I guess they did make it a separate bone here. I thought it was fused. Some of the models, they fused them to make it, I guess, to save money. But yeah, so scaphoid, lunate, triquetrum is back there. This little guy sitting on top is the pisiform. So that's the four ones in your proximal row. Then you go to your distal row and go back to lateral. So this is what? Trapezium. Trapezoid is this little guy. Capitate, and then this guy is the hamate. The hamate you can kind of tell because it has a little thing called the hook. So this little thing coming up here is the hook of the hamate. Now, other things to show you. Oh, this sort of got, oh no, it's okay. This is your trapezium, like I said. Okay. This is your metacarpal from your thumb. Okay, and this is the spot here where you have your only saddle joint in the body. Okay, you got the little saddle coming from the metacarpal, and then the trapezium has sort of a saddle shape on it as well. So that allows your thumb to do this. It also allows it to do that. Right? And if you combine the movements, you can do the circumduction. Right? All kinds of things. You can do the opposition. Right? All right. These then are all your metacarpals. These are your phalanges. Again, there's going to be 3 phalanges in all of your fingers except for your thumb, just like there is in your foot, everything except for your big toe. And this one would be the, which phalange?
Middle.
Proximal.
Oh.
This one would be the middle, and then this would be distal. So proximal, middle, distal, proximal, middle, distal, proximal, middle, distal. In the thumb, you can only really talk about a proximal and a distal since there's not a third one to call the middle. All right, that's that. I'm going to go to the lower extremity. Where was it? I know I brought it in here. How can that?
You need a knee?
No, I brought a pelvis in here. This kills me. All right, hold on a second. I'll find it. Just wait. Put everything on pause. Shoot. What did I do? I probably dropped it. I do this at my house all the time too.